Hey guys, today we will learn about LPP and this is the lecture 2. I hope you all are doing good. So let's get started. So in the previous lecture we learned about LPP, that is linear programming problem. Actually it is not a program, okay, I had done a mistake. So we have seen that in the previous problem there was two products and two resources, and we were using those resources to make two products and there were some profits. So we formulated the formula and we solved that, and we are moving for next problem. So I will request everyone who is watching this video, please sit with a pen and a paper, because I am also writing with my pad and I have this pen as well. Okay, you also sit with a notebook and a pen and you write with me. For you only I am writing the questions and I am solving right in front of you. So you also do some labor, because at the last you will write the exam. You are not going to express your answers. Okay, so let's get started. So let me recap the problem that was taught in the previous lecture. So it was what? LPP. Okay, linear programming, not program, it's problem. So the mathematical model of LPP, let me write here for you. Of LPP, we have to maximize. Sometimes we need to minimize as well, but as we have seen the previous question, there was a case of profit, so we need to maximize the profit. Yes, so I am writing a maximize, or you can minimize as well. When it comes to the resources, we try to minimize the resource, okay, whereas we want to maximize the profit. So what do you want to maximize? Z equals to Cx. It is just like the formulas, okay. So then series of Ax, which can be less than equals to or greater than equals to b. We can say this is as constraint. Okay, I hope you know the meaning of constraint, or x is greater than equals to 0. What is x? X means product. Obviously it will be greater than 0. Can a product be minus in negative? No. Yes. So this was the thing we learned in the previous lecture. So how to formulate LPP model? So I will request you, do not focus on solving the problem, just watch me how I am thinking to solve the problem, because the first you will think, then you will solve. So first you need to learn how to think the problem, then you will solve the problem. Okay, so then learn how to think. So see, I am writing a second question. The question goes like, a manufacturer produces two types. A manufacturer produces two types of product, A and B. This problem is just like the previous problem. It is, I am doing for you for your practice. See how I am thinking to solve the problem. And sales, बेच दिया भाई, them at a profit of ₹2 on type A and ₹3 on type B. Each product is produced on two machines, that is M1 and M2 each. So I hope you are writing with me. If you are not writing, then please leave this video, because I am writing. So you need to write, because I am also putting effort to teach you. You will have to put effort to learn as well. On two machine M1 and M2, type A requires 1 minute of processing on M1 and 1 minute of processing on M2. Okay. Sorry guys, it is 1 minute of processing on M1 and 2 minutes of processing on M2. It is for type A. Now you have to write for type B as well. Type B requires 1 minute of processing on M1 and ख़त्म मत कर, मैं भी खाऊंगा, and 1 minute.
Repeat this line again.
So processing on M1 and 1 minute of processing on M2. So now the constants come. Machine M1 is available for not more than 6 hours 40 minutes, while M2 is available for 10 hours during any working day. Formulate the LPP to maximize the LPP, or you can say the profit. Okay, so maximize the profit I am writing. Okay, so see how you will get the approach. First thing is profit. How you will get the profit? From the products. How many products you will produce, and that much profit you will get. Okay, see once again, if you will produce 5 products, then by selling those 5 products you will gain the profit. So the profit is directly proportional to the products. So how you will maximize the profit? By maximizing the sales. So see here, what are the types of product? There is a type A and there is a type B product. So see, I am writing the solution as we have formulated in the previous lecture. There is a problem that I formulated by doing some square. So in the same way we will also do the we will approach this problem in the same way. Okay, first you make a square. Okay, write product A, write product B, write machine 1, machine 2. Okay, now here the game is over. You need to put the information, put right variables, and you will get the answer as well. See, नहीं पहुंच रहा तो कुछ कर, बात कर ले.
Hello? हाँ?
So machine 1, okay, see here I am telling you, type A requires 1 minute of processing on M1 and 2 minutes of processing on M2. So what you will write in case of M1? 1 you will write, because it requires 1 minute of processing from M1 for A. So how much time it requires for M2? 2 minutes. So write here 2. Next comes for B. See, it is written here 1 minute of processing on M1 and 1 minute of processing on M2. So write here 1 minute of processing of M1 and 1 minute of processing on M2. So what was the profit from A? See, so profit from A is rupees 2. Yes or no? It is written in the above. I am highlighting for you. This is profit from B and this is profit for A. So right here profit is rupees 2 and profit for B is rupees 3. Okay, and now here I want to ask you a question. So what is the constraint for M1? It is 6 hours 40 minutes. Okay, see here 6 hours 40 minutes. Whether you will write here 6 hours 40 minutes or what? Now here is the question and it's a logical question. If you write 6 hours 40 minutes, it's going to be difficult for you to solve the problem. Because how you will write this 6 hours 40 minutes in, you will get the decimal. Okay, you have to solve in decimal. So to make it easier, convert it into minutes. Okay, so 6 hours 40 minutes. As we have written here 1 minute, as we have written here 1 minute of M1, 2 minutes of M2. So if you write in hours, so you have to convert those 1 minute and those 2 minutes into hours, which is getting more complex. You can do, I know, but it is getting more complex. We need to not to do in a very complex manner. That's why we're reading this LPP to solve a problem in a very easier way. Okay. So we have to convert this 6 hours 40 minutes into minutes. So what is 6 hours? 6 hours into 6 hours into how much? You will multiply so that you will get into minutes. 1 hour 60 minutes. So 6 hours 360 minutes. Then furthermore 40 minutes. 360 minutes plus 40 minutes is 400 minutes. Okay, so you write here 400. And 10 hours, 10 into 60, 600 minutes. Now the case is over. Just we need to put the right variables and we will get the answer here itself. So which one you will take the variable to solve this problem? Will you take it M1 or you will take the products? As I have told you that the profit is coming from your product, not from your machine, how much time the machine is taking to produce. No, how many products you are producing, from that the profit is coming. So you have to take the products into variables, or you can convert. See, you can take your variables in your own way. I am taking x1 and x2. You can take it in your own way. You can write A, B, Shahrukh Khan, Amir Khan. You can write anyway. Okay, no problem. So we need to solve this. What do we need to maximize, students? So what we need to maximize, guys? We need to maximize profit. So if I am taking A as x1 and B as x2, so and we are getting profit of 2 rupees from one product of A. So how much profit we will get from x1 products of A? Obviously 2 into x1 right here by closing your eyes. Then how much profit we are making from B? We are making rupees 3 profit from one product of B. So how much profit we will make from x2 products of B? Obviously 3 into x2 by closing your eyes. Now see, we need to formulate the constraints. I am writing for you subject to constraint. What will be our subjects to constraint? These machines, these are the constraints. This will run, M1 will run for 400 minutes and M2 will run for 600 minutes. So these are the constraints right here. X1. So if X1 number of products has been produced, then how much time M1 will take? See here, for A, M1 is for one product of A, M1 is taking 1 minute. So for 10 products of A, M1 will take 10 minutes. So for X1 products of A, M1 will take 1 into X1 minutes. So write here X1 and if there are x2 number of products, for one product of B, M1 is giving 1 minute, then for x2 number of products, M1 will give 1 into x2. So, this is x2. So, the total time that x1 M1 gives is should be less than equals to 400. I think you got me. I am explaining again. Okay, if there are x1 products of A, M1 is giving a 1 minute for one product of A, then you have to multiply 1 into x1. Yes or no? And if for x2 M1 is giving 1 minute, then you will multiply 1 into x2, 1 into x2, as simple as that, which is x1 plus x2 is less than equals to 400. Yes or no? Yes. So, in the same way, this is the constant for M1, 400, and what will be the constant for M2? See here. See, you can judge from here only. It is written 400, it is written 600. You can look in this way as well. Okay, this is the trick that I want you to derive by yourself. So, it is written 600. So, how that as I explained you about A, in the same way you do by yourself and write what will be the answer for M2, that is the constant for 600 minutes. Okay, okay, I am writing for you. You pause it and you write, then you look to the answer. Okay, so see, there is 2 minutes for A, so 2 into x1 plus 1 minute for B, so 1 into x2 should be less than equals to 600. Similarly, 2x1 plus x2 is less than equals to 600. Okay, we got our two constraints, M1 and M2 constraints, and we have to maximize the profit. So, you got two equations for, by solving which you will get the value of x1 and x2, and you can put these values in place of maximize formula to get the maximize profit. Okay, this is the problem that is similar to the previous problem. Okay, now we will dive into another newer problem. Okay, so this is problem 3, I guess, and I would like to discuss some theories with you. You have to keep in your mind. Okay, so to solve a LPP, these are the things you need to note. Okay, identify decision variable. Okay, decision variable means on the variables on which your decision depends. That means that is the profit on which the profit depends. The profit depends on the number of products you produced. Okay, so right here, identify. The first step is to identify decision variable, and the second thing is create objective function. Okay, in the previous problem, what was the objective function? This was the objective function to maximize. Okay, this was the objective function. Okay, so create objective function. Another one, next, create constraint. M1, M2 is a constraint, 400 minutes and 600 minutes. Okay, next, the model that is a square that I made. Okay, so let's see another problem whose name is production allocation problem. So let me write the question for you, and guys, see, my friend is also studying with me and he is also writing with me. If you don't believe, you can hear his voice as well. Hey, कुछ बोल दे यार, कुछ बोल दे.
हाय गाइस.
जोर से बोल, खाया नहीं क्या?
क्या बोले?
ठीक है, he is sitting near me and he is confused what to say. You can hear the laughing as well. Okay, so
Come on, sir.
ठीक है, चलो शुरू करते हैं.
क्या
चलो.
बना रहे हो आप? Join me now.
ठीक है. Okay, this is the example 3. This is the example 3 I am writing for you. So production allocation problem. Give heading. Production allocation problem. Okay. So a firm produces 3 products. These products are processed on 3 different machines. The time required to manufacture 1 unit, let me write in numerical, 1 unit of each of the 3 product, and the daily capacity of the machines are given in the table. So guys, here is the table for you. So let me write the question. There is, so you can see there is a machine M1, M2, M3, time per unit that is written in minutes. So machine capacity, it is written machine capacity. So this is P1 product, this is P2 product, this is P3 product. Then this is 2 minutes it is taking, it is 4 minutes taking, it is 2 minutes taking, it is 3, this is 5, this is 2, this is 3, this is 440 per day. This machine capacity, this can produce 440 products per day. This can produce 470 products per day. This can produce 430 per day. So guys, this is the table for you. Okay, according to this we will solve the problem. So it is required, continue the question. Okay, it is required to determine the number of units to be manufactured for each product daily. The profit per unit for product is three the profit per unit for product P1, P2 and P3 is rupees 4, rupees 3 and rupees 6. So formulate the LPP. So guys, this is a new type of problem, so do not get afraid of it. I am simplifying this problem for you. Okay, so we need to first see, remember there is something written at the last, profit per unit for product, okay, is 4 rupees, 3 rupees and 6 rupees, and what this profit is depending on the products. So what do you have written here? Identify decision variables. Here decision variables are products. We can take x1, x2, x3 or p1, p2, p3. Let me take p1, p2, p3 according to the question so that it will be easier for us to understand. Okay. So I am adding the solution for you guys. So what we need to maximize? We need to maximize z equals to, z means the profit. Okay. 4p1, that means you are getting profit from p1 is how much? 4 rupees. For p2 3 rupees. For p3 6 rupees. Yes, you can see I have written 4 3 6. So write a 4p1 plus 3p2 plus 6p3. And what are the constraints? See how you will identify the constraints. See the capacity written, machine capacity. For M1 440, it can produce 440 products, not products. Means if M1 is producing, for example, M1 is producing raw material nuts. Okay, then it will produce 440 nuts per day, and we will use those nuts to form some other product. Okay, so think like that. So how much it is producing this M1? M1 is producing 440. So let see we will have to constrain the M1. So for P1, M1 is how much M1 is used? 2. For P2 how much M1 is used? 3. For P3 how much M1 is used? 2. So total numbers we have taken P1, P2, P3. Accordingly we will put this one, like for M1 it is 2x1 plus 3x2, sorry guys, P1, P2 plus 2p3 should be less than equals to 400. And for M2 similarly you put and find, pause, find, then see. I am writing for you 4x1 plus 3x3 less than equals to 470. Pause, then see. This is 2p1 plus 5p2 less than equals to 430. Okay, you can see in product P2 M2 is not been used. In product P3 M3 is not been used. Okay, so these are the constraints. We have written the constraints. This is our objective functions done, constant done, identified decision variable done, and obviously if you have done these three things your model is also done. I hope you all are getting these things. Okay, let me recap this problem for you. Okay, listen quickly. There are 3 products. Okay, 3 products are being produced by 3 different machines. Okay, and these machines have their capacity. M1 has 440, M2 has 470, M3 has 430 per day. That means M1 is suppose producing okay, you are making mixed juice. Okay, if you are making a mixed juice, M1 is apple, M2 is orange, M3 is pineapple. Okay, M1 is if M1 you have if M1, that means apple, you can only use apple 440 per day, and M2 is orange, you can use 470 orange per day, and for M3 you can use only 430 pineapples per day. Think like that. We will use these products, these fruits, and we will make the juice of them, and we will use the products P1. Like there for P1 we can see, we can see there is 2 apples, 4 oranges and 2 pineapples we used for making P1. Okay, so we will grind them and make P1. Okay, for P2 we will use 3 apples, 5 pineapples, grind them and make P2. The taste will be different. P2 taste will be different, P1 taste will be different. And for P3 we will use 2 apples, and 3 oranges, grind them and make a juice that is P3. Are you getting? I hope you will be. I hope you are getting. And in the same way, we have formulated the constraints here. For M1, 2 apples, 3 oranges, 2 pineapples. For M2, how many apples are been used? 2 into P1, 3 into P2, and 2 into P3 apples are been used. How many number of oranges has been used? 4 into X1 oranges. This one actually P1, this one actually P3. 4 P1 oranges, 4 into P1 oranges, 3 into P3 oranges. Total number of oranges that been used is 4 into P1, 3 into P3. And total number of pineapples used 2 into P1 and 5 into P2. Are you getting or not? Yes. So this is the thing that we need to do. Okay, this is as simple as this. Okay, just it is your perception, how you are looking at the question and how you are understanding the question. Once you understand the question, you formulate the profit, you formulate the constraints, and in front of you will have the answer. Till now we have not discussed about how to solve the LPP. There are many methods to solve the LPP as well. Okay, we will discuss this. We will discuss this further in our videos. Okay, so this was the example number how much 3. Now we will study example 4. So by learning these examples, you will be getting familiar with the problems that we are facing, so that you can formulate your own formulas, and you will be able to solve on your own. There is a problem after this, which one I will solve in 2 ways, and I will show how one is solved in some book and another one I have solved my own. Okay, I will tell you how I have done that one. So there is example 3, blending function. Right, example 4, blending function. Okay, do not get afraid with the word blending or something. This is just a word, ignore that one. A firm produce an alloy Example of an alloy. Amalgam is an alloy. Yes or no? Amalgam is a alloy of mercury. It's a 10 class patho bhai.
Amalgam is whiskey.
10 class patho.
But sir, amalgam is whiskey.
A firm produce an alloy having the following specification. What are the specifications? I am writing, look. Specific gravity should be less than equals to 0.98, and chromium greater than equals to 8%. Melting point कितना? Less than equals to 450 degree centigrade. Okay. So raw materials used are A, B and C having the property below, used to make the alloy. Okay, write the raw materials primary specific gravity, that is A, for B and for C as well. Specific gravity for A is 0.92, for B is 0.97, for C is 1.04, and chromium is 7%, this is 13%, this is 16%, and melting point is 440 degree centigrade, 490 degree centigrade, 480 degree centigrade. Okay, and cost of the various raw materials per unit ton is cost of the various raw materials per unit ton is rupees 90, rupees 280, and rupees 40 for A, B and C respectively. Find the proportion in which A, B and C be used to obtain an alloy of desired property, while the cost of raw material is minimum. Okay, so how we will do this? So you have the products, take x1, x2, x3, A, B, C, Shahrukh Khan, Amitabh Bachchan, Hrithik Roshan, Allu Arjun, whatever you want to take, you take. Okay, so let's dive into the solution. Okay, what we have to make? We have to make a alloy, and we have the constraints here. See what are the conditions for making an alloy. The alloy should have specific gravity of 0.98. The alloy should have the chromium content of 8%. The alloy should have the melting point that is greater than equals to 450 degree centigrade. Okay, and chromium should be more than or equal to 8%, and specific gravity should be less than or equal to 0.98. These are the constraints. Okay, so in this mathematical problem, you do not think in a chemical way. How you will do this? How this will happen? No, that much questions we do not need. Okay, this is a mathematical problem. We will have to solve in a mathematical way. This specific gravity will come after adding these specific gravities. Okay, ABC. Are you getting? Yes. So if you have taken the products x1, so let us take as A, B, C. Okay, so we have A, we have B, we have C, and we have to maximize what is the profit. That is, we are getting the profit from a ton is rupees how much? 90 rupees for A, 280 rupees for B, and 40 rupees for C. So as I have told you earlier how to calculate the profit, write it yourself and then come to the video and see the solution. Okay, so I am writing for you 90x1, or you can take A, or 280B plus 40C, and we have the constraints. What are the constraints? What are the constraints? See, how much specific gravity should have A? A should have 0.92 specific gravity. How much specific gravity should have B? B has 0.97 specific gravity, and how much specific gravity has C? 1.04 C. After adding these specific gravities, what should be the constant? That should be less than equals to 0.98. That means you have to use A, B, C, the specific gravity of A, B, C in such a way that, so guys, we will solve this problem. There is one alloy and we have three raw materials A, B and C. We will use the raw materials in such a way that less number of raw materials, less amount of raw material is used to make an alloy. So we have the constants here. Okay, so what is the Z? So here we need to minimize Z, okay, because this is the cost that we are spending on producing an alloy. So the cost should be minimum. So Z is the cost that is been used to produce an alloy. Okay, if you will produce an alloy at rupees 5, then you can, if you will sell it at rupees 10, you will have a profit margin of 5 rupees. If you will if you will spend 10 rupees and you will sell in 5 rupees, you have a loss of 5 rupees. So here, to make a profit, we have to put less amount of money, we will invest less money, so that after selling it we will get maximum profit. So here we have to see that how you can minimize this cost of production. So see, the constants are 0.92 A and 0.97 B and 1.4 C. So these are the specific gravities of A, B and C. So after adding these raw specific gravities of raw materials, we should have a specific gravity of less than equal to 0.98. Yes, and for the same chromium, see, the constants are written. Okay, you have to refer these constants as it is written above. So for chromium also, I want you to formulate by your own and then come to see the solution. For chromium, you have to use, it is written 7%. 7% how much? 7 by 100 into 100 you do and you get 7%. So how you will write this 7% in numerical value? Do 7 by 100, yes or no? So write here 0.07 A plus 0.13 B plus 0.16 C, that should be greater than equal to 0.08. okay, and for melting point, 440 is the melting point. So 440 for A plus 490 for B plus 480 plus C, that should be greater than equals to 450. And we are done. This is the model that we are looking for. So if you once you get the model, then there are different ways to solve this model. Okay, in the previous lecture I told you simplest way that you equate it and you the maximum thing you will get the maximum. That is a manual method. Okay, there are ways to solve this problem, linear problems. So these are how many examples we studied in this lecture. We studied four examples, in which the first example we had learned in the previous lecture, and these are the three examples we learned. Second example was similar to the first one, and third example was production allocation problem, where you have your machines and you have the machine capacity, and then we have the blending problem, and then we have that much. Okay, the two new problems are there, blending problem and the production allocation problem. Okay, that much for today. So that's all for today, guys. Keep learning, keep exploring, practice more problems. So in the next lecture I will discuss one of the problems I have, in which we will use two methods to solve the problem. One is in the book and another is of mine own, and I will tell you how I thought of solving that problem. And that's it for today. So take care. This is SR signing off.